Hi, my name's Brett Sloman. I'm a product manager at Electa Software working on the Monaco treatment planning system. Today I want to show how to set up a plan for multiple brain metastases using the Versa HD and Monaco 5.1. This particular patient has 5 lesions in the brain, reasonably well spread apart, with a couple of them being reasonably close to the brainstem, so that's probably the main concern for the organ at risk. Otherwise we have the optic structures, the optic nerves, optic chiasm, eyes and lens to be concerned about. So I'm going to go ahead and load a template to get started with the plan. Okay, so I've filtered my anatomical sites down to brain, so I can choose a brain template, and I'm going to go with this one here which I've used before, which is a single ice center treating all and any lesions to 2000 centigrade, again using the Agility MLC on the Versa HD. To simplify things, I've created a auto margin around all of the targets, called that all targets, and that's a 0 expansion on all of the PTVs. Okay, so the template has brought in the fields, the calculation properties, grid space set at 2 millimeters, 1% statistical uncertainty. If you use something different in your clinical setting, by all means, you'll change those and save those with the template. Now, the other thing that the template has brought in is the IMRT constraints, and although we have a lot of structures that we're interested in avoiding in this case, the basic constraints are quite simple. All of the targets going to a dose of 2000 centigrade, a quadratic overdose of 2250 with a RMS overdose of 150. I'm using the conformality cost function to keep the dose outside of the targets down for all of the patient. Now, in this particular case though, because the brainstem is kind of close to a couple of the targets, I'm going to go ahead and bring the brainstem into the IMRT constraints and make sure that we don't get any excessive dose to the brainstem. So I'll select the brainstem and move that up in layering order. And I'm going to set a serial cost function on the brainstem because it's a serial organ. We generally want to keep the brainstem below 1800 centigrade for a 5-fraction delivery. We'll use a power law exponent of 18, which is quite a high power law exponent, and this is really emphasizing just how serial we want this organ treated. I'm also going to use the multi-criterial option because really I feel like we can do a lot better than 1800 centigrade to the brainstem, and in these sorts of cases often the patients do very well and may come back for retreatment in the future, so we want to make sure we have as much of the brainstem speed as possible in case of future treatments. Okay, so at this point I'm going to start the optimization, and we'll let it run and just see how well the system does in terms of dropping that brainstem dose, hitting the target doses, and also the conformality on the body to try and keep the overall dose to the brain and to everything else down as low as possible. Okay, so now the plan is finished, and we can take a look and see just how well the system has done in terms of meeting the constraints. It's kept the brainstem way down below the original 1800 centigrade, and also the conformality that started at 0.6 is down to 0.25, so you can see that the isodoses are wrapped very tightly around the targets. All of the optic structures are well and truly being spared, and we have good target coverage, so this is a nice plan. Thanks for watching this video on stereotactic treatment. Keep an eye out for more features on the Monaco 5.1 release.